Gaussian mixture models, GMMs.
Right.
This is where we get into probabilistic clustering.
GMNs take a fundamentally different route. Instead of assuming a cluster is defined by a single point, its mean. GMM assumes that the data was actually generated by a mixture of several probability distributions, specifically Gaussian or normal distributions, those familiar bell curves.
Okay, so instead of forcing a point into one cluster or another, we're thinking about the clusters themselves, probabilistically, based on where these hidden bell curves overlap.
That's the core idea. The probability distribution of the entire dataset, expound, is modeled as a weighted sum of individual Gaussian components.
Right.
Each component has its own mean, its own covariance matrix, which defines its shape and orientation.
So it doesn't have to be spherical.
Exactly. It can be oval, diagonal, whatever the covariance matrix dictates. And each component also has its own mixture weight, saying how prominent that component is in the overall mix.
This sounds much more flexible than k-means,
Yeah.
especially for real-world data where boundaries are often messy.
It is much more flexible.
So how does the model figure out the parameters, the means, the covariances, the weights for these underlying Gaussian distributions? It sounds complex.
It is, and it can't be solved directly analytically.